Today on the show, I speak with Moses Guttman, CEO and co-founder at ClearML. There are many parallels we could draw between the software development lifecycle and the machine learning development lifecycle. In fact, we're going to compare some of those in the interview. But I hope most listeners would realize, assuming they can follow the same path, is truly squishing a square peg in a round hole. The practice of machine learning in production is a somewhat tricky one, but luckily there's a lot of lessons learned and now tools available to help organizations do this.
So I'm Moses Guttman. I'm the CEO and founder of ClearML.
And can you tell me a little bit about what ClearML does?
ClearML is an open source MLOps solution that is really end-to-end. So try to cover all the different bases that ML practitioners don't have to spend time writing boilerplate code, rebuilding packages, doing DevOps stuff. So we can actually streamline this entire process. And I hate to say that, but probably more complicated to manage than kind of our standard software development processes.
I've had a familiarity with the term DevOps for quite some time. I never filled that role, but understand a bit about it and respect those professionals. It was only in the last couple of years I started hearing the term MLOps, and I felt like I intrinsically knew what it meant, but for those that don't, is there any standard or maybe just colloquial definition?
I am not sure that there is. In the last couple of years, it kind of crystallized to what it is now. I think that 2 or 3 years ago, you asked different people, you got different answers. So right now, I think it's about operationalizing machine learning as in general, like everything that has something to do with the software engineering aspects of getting machine learning to work, whether this is part of the development or part of the production itself. So things like serving, monitoring, etc.
A lot of my own professional experience has been on the deliverable being a model artifact. So the training data, the cross validation, the regularization, all the machine learning fun stuff or stuff I consider fun. That was my job. Maybe I had some assistance. Sometimes I did, sometimes I didn't. But much like software, who would deliver, a binary compiled version, I was delivering a compiled model in some sort of either pickle file or Onyx file or something like that. And that was our relay race. I just handed it off. Is that a standard or are we moving in new directions now?
I think that it used to be that way, and now we're kind of evolving. I think that the main difference is when we think about software development and releases, we have kind of a Jira ticket or I don't know, Monday or however you manage your projects. The only question near a ticket or a feature or a bug is how long would it take to fix it or build it? And when we think about models, sometimes it's just, yep, that's not feasible. That's a valid answer. And then the second one is, okay, so what's the accuracy? What am I about to get? And unfortunately, these things actually change. So from a software development perspective, you build a feature, it's there. Unless you ruin it in the next version, it's working. But when you think about models and they rely on data and data might change, you don't end up with anything that is stable for more than, I don't know, depending on the vertical, but it's never actually stable. So you'll have a next version that is basically might be the same thing, only trained on new version of the data. Like it's not the same as if you want to compare it to software development, it's not the same as adding a new feature or debugging something. It's actually a part that, at least in theory, should be automated. There is no ingenuity there, there's no research. Things just change. And that's the main difference. It's not you don't package it once and you deliver. You package it once and then you want to constantly update and grow with whatever you're delivering it with and whatever it relies on.
So, what are some of the tools a team needs to make that process smooth and to address the points where it's different from software development?
For a lot of teams, and I think that this is where we're coming from, we're all at the end software developers. We're thinking about them as tools for packaging software. So we think about containerizing our code base, and we think about the code base as something that is static, and we think about getting everything into a single place and then just dropping that somewhere else, and now we're done, just tag it. But when we think about model deployment, we have to think about the fact that the container itself now needs to contain a few more things than just code and compiled code. Right now, it might need to contain some artifacts, as you mentioned before, and maybe some configurations, and maybe it relies on data. And there's a process to kind of the equivalent of compiling code, but now it's retraining on data. But again, with compiling, it's unless you change the compiler, it will just work the second time you do that. With training a model, you push different type of data, it might not actually work. So you have to prepare yourself for the fact that whatever automation that you think about, like think Jenkins, for example, might fail, and it's not a binary decision. It's now you have a graph and you have to decide whether this is good or bad. So kind of preparing yourself to the fact that you're not packaging it and then totally forgetting about this. You're actually starting a process. And that process doesn't actually start when you think about the deployment part itself. It actually starts when you're thinking about the development. Because at the end you want to abstract a lot of things so you can control them after the fact, after everything should have worked, and now you want to retrain it or adapt it to the new type of data.
Yeah, the comparison to software is one that I think is very helpful, and a lot of people fail to see some of the subtlety of. Like you were mentioning, if you deploy botched software, the feature breaks right away, or maybe the CPU goes to 100. There's usually some immediate indicator. But if I train a new model that's reading users' behavior and that behavior evolves in response to the model, I'm not going to notice that immediately. It might take time for us to recognize our couponing solution had a different outcome than we expected. Do you have any, whether it's specific or general, maybe anecdotal examples? How are people able to do ML ops in production post release?
Okay, so we touched DevOps before. So from a DevOps perspective, we think about logging. That's basically console outputs and some metrics to basically make sure that the machine is working. You're not consuming too much memory, or the memory consumption did not increase. Same with storage, same with CPU. You see a spike, you say, okay, something is wrong. You either switch machine or you ask someone, did you deploy a new version? And that's basically it. And then you use the logs for forensics, basically, to trace back what happened. Oh, yeah, someone actually upgraded the version. That version contained a bug. And this is why we see increase in memory, and it kind of exploded. But when we think about models, now we have to think, okay, so we still have the CPU, we still have to monitor that, we still have to monitor the memory consumption, etc. But now we also have to monitor some other metrics that are the byproduct of the model itself. So, for instance, performance, is this actually being used? And how frequently it's being used, and the latency it causes, and then maybe the outputs. So we should probably see into what's going on. So if before we were looking for a spike in the utilization or whatever affected the process itself, so the outcome of that is obviously whatever we can measure, which generally is memory and CPU and storage. Now we have other matrices that we can push into some logging solutions to monitor, and we have to have those, but it's essentially the same thing. We just want to make sure that it's actually working properly, but now it's more complicated. But just the subtleties are, at least in theory, are the same. You're still looking for an increase. Like imagine a memory leak where only after a week you can kind of see, oh yeah, we definitely have a memory leak. We should not see that increase. It's the same with kind of model drift going towards a direction that it should not. So at least in theory, it's very close, but in practice, it's actually more than one. So now, if in the original you just had one dimension, right? It's, for example, memory. But now, basically, what you're looking for is a deviation in the probability of different answers. So now, instead of logging a single value over time, you have to log a histogram over time, because what you're looking for is a shift in the distribution of a certain value, because it was never a fixed value.
Well, it's obvious we want to instrument our machine learning processes. If they're doing anything of consequence, they should have the same rigor of monitoring and telemetry and that sort of stuff. But I also know a lot of machine learning projects begin in a fairly sloppy way, right? It's just some Jupyter notebook that can't be rerun. That's 1,000 pages long. What is the right time to pick up the proper tooling and get it all instrumented?
I think that before we kind of used to think about it Like back in the day, it was okay, you write your algorithm, and then someone else will take that algorithm and write proper software on top of it, and then that software will be used. Like these were two different steps, or three, or whatever. And that was very easy to understand. Oh, that's my place, that's your place, that's how we work together. But I think these days, software development kind of changed, and now we have CI CD is kind of okay, that's basically the baseline. That why do we have to waste time on this repackaging, doing things manually? It should be part of the development process. And the same should happen with machine learning. I don't think it's there, but that's what we're preaching to. So instead of kind of, as you mentioned, like, hey, that's the first step. That's build the algorithm. You end up with a very long Jupyter notebook that, by definition, is not linear. So hopefully it works A to Z, but sometimes it doesn't.
Uh-huh.
Most of the times, right? And then you say, okay, I'll scratch my head and I'll give it to someone else, and they'll take the proper code from it, maybe, I don't know, like 10%, or how much code we actually need, and they'll build something out of it. And then they build, and then someone else tests it, and then they come back and say, you know what, it doesn't really work because we changed, or the data changed, or something changed. And then you restart that process, and that process just becomes so slow that you end up with a model that by the time you want to deploy it, things already change because you have other departments or other aspects of the product constantly changing, right? That's a word that we live in. Unless we kind of embrace this CI/CD approach of no, it should be part of the development. It's not that complicated once you start using tools, then you actually skip over everything and you can start to deploy and actually use. It's not about deployment, it's actually about using. It doesn't really matter how. Your model very close to the development process itself, because the development doesn't really end. That's the point on kind of the retraining aspect. And that's basically what we're saying is start to think about machine learning as a CI/CD process rather than kind of a separate research development production process.
ClearML is a solution with a number of components. If I go get the open source version, I don't know that I'm adopting every piece on day one. What's a typical path? What do people start getting advantages from first?
So I think the lowest hanging fruit is always experiment management, because that's always the first step, like writing your code, like your Jupyter notebook. And the first value is, I think, oh, you can see what I did yesterday because I never bothered to store my Jupyter notebook or the graphs or actually push it into a Git repository because it's a Jupyter notebook, right? And even if I was working inside a Git repository, which is hurrah, well done. I'm still developing things, and a lot of stuff is uncommitted, and you don't know like magic numbers, etc. And when you want to trace back, because sometime it like a day before it actually worked, and you want to compare, now you can. So that's kind of the first step, is embracing the fact that you should have logs when you're actually developing the code itself. And that's basically the essence of experiment management. With ClearML, we added something to that, so it is easier for users to adopt to their workflows. Basically, we said, okay, you know what, guys, we'll do the heavy lifting of whatever you guys are logging to, and we'll catch it in flight so you don't have to change your code base. So we work very hard in order to make sure that ClearML logs everything for you, and that you don't actually have to add the logging calls to your Python code. You can, but you don't have to. And that's important because it makes it easier for researchers to integrate to their current workflow. And from that, you actually move into, okay, so how do I automate things? Actually, the second step is a more complicated one. That's the one that makes it a CI/CD process, right? That's moving from running your own code and doing your own QA process, or QC, if you will, for your model, to actually running it on a remote machine. And then once you have it on a remote machine, then the rest of the steps, they become trivial, kind of changing configurations and arguments, etc. But I think that the move from step one to step two, that's I think that's the first challenge for a lot of users. But the value is huge. So once you do that, you can actually start to think of it as outsourcing. You build the original template and then you ask other people, hey, can you test it on new data? Because now you can. It's basically rerunning things from a user interface, changing some parameters and watching the graphs. That's it. You don't have to understand what I did in order to run the model or the process that I built. And now a lot of people can use that.
So yeah, in a lot of machine learning projects I've been on, I've kind of been the bottleneck because I'm the one who has the, fit and predict methods in my notebook. And I've always wanted to collaborate a little bit more clearly. With experiment tracking, I can share, whatever metrics I have, accuracy, F1 score. So it's nice that I can socialize those with my team. Could you expand a little bit more on the opportunity for collaboration where people can maybe do some parameter tweaking themselves?
The way that it works is when you run your code the first time, the way ClearML works, it logs everything for you. So it actually stores your Jupyter notebook or a link to your Git repository. And it analyzes the code so it knows which packages you used and the exact versions because we're messy and we don't always actually freeze versions, etc. And it works on our machine is a famous sentence. It also allows you to have external interfaces, which is huge for Jupyter notebooks because we don't have like arg parser for Jupyter notebooks. It actually allows you to add like a dictionary or an object, and then later you can control it. Without getting into the details, the idea is that now you can add as many parameters as you like, including configuration files, etc. Basically, think of it as first step is just logging what I did, just so I know, oh, I used those magic parameters or values. Now, the second step, and that's the important one, is once you see it in the experiment management, which I think that by now everyone can imagine how that one looks like. What we added is the ability to take any experiment in the experiment management, clone it, meaning creating a copy, changing the values, and then sending it for execution. And that cloning, changing, and then watching again, like the output, someone else can do, not the creator or the original author of the code itself. Putting aside the magic behind the scenes on how we actually deploy it and make sure that everything works, that's the kind of the orchestration part of ClearML. And again, we're not covering all the different modules, but I think those are the most important part, at least when you get started. With that capability, someone else that you shared your experiment with can now actually use it out of the box without understanding how it works because you, the author, just created an interface for any user in the system to launch it on a remote machine or think like on-prem Kubernetes, cloud instances, whatever. ClearML does that for you and get the output of your code.
So that part still feels a little bit magical to me. I have a Jupyter notebook on my local machine, which I have configured in a very unique way. No other machine in the world is quite like mine. And I've got an AWS account and a credit card. How do I leverage ClearML to push the compute into the cloud?
Right. First, you're absolutely correct. It is magic. I mean, kind of like any other magic. There's a lot of engineering behind the scenes, so it's science, but a lot of magic. So what is actually happening is when you run it on your machine, we store the Jupyter notebook as a Python code. We do some magic stuff so it actually works. We also say, oh, you used a specific version of NumPy and it worked with your specific version of scikit-learn or XGBoost. And that's the Python version that you're using, which is important because otherwise it'll break. We package everything, and these are the parameters that you exposed because you basically said, hey, that's my dictionary with parameters, or that's my file with configurations. And we store everything in the backend. So the backend is kind of, think of it as also as a control plane. There is another part of that control plane that we call the ClearML autoscaler. Basically, we have an autoscaler for most of the popular cloud providers. Now we're adding a new one that is 100% green. So I am not sure when the press release is going to be out, but maybe with a podcast. So we'll have a 100% green cloud provider as well.
Very cool.
Right? That's what we thought. The way that it works is you have the ClearML autoscaler saying, okay, give us the credentials so we can spin an instance for you. In that instance, we monitor that instance. We deploy the ClearML agent, which is kind of the orchestrator of ClearML. That agent connects to your account and it starts pulling jobs from an execution queue. So think of an execution queue as a way to say, oh, here's a list of jobs. That's the order. The order kind of translates into priority. First, do this one. It's probably more important. Do the first and then the second, etc. And that agent will pull jobs, set up the machine itself inside the cloud instance. So it will spin the right container for you or do it bare metal. It'll pick the right Python version. It will install everything that you need in order for your code to work. It will take the code that we converted into Python when you were running it on your notebook, because only then we had all the information that we needed in order to convert it. So we already converted it into Python code, and then we'll run your Python code. And every time that you actually logged a parameter, it will say, oh, now you're not logging that hyperparameter. Now you're doing the opposite. Now we're taking the new parameter from the backend, because your friend might have changed that, and we push it back into your code in real time. So now you can change your flow without changing the code. And that's part of the magic.
I like this workflow. I'm curious, how does it marry up against where I would store things in Git?
Oh, okay. So that was totally disconnected from everything, right? We haven't touched data, which we might if we have time, and we haven't touched Git. So let's assume for a second that I'm not writing my code inside a Jupyter notebook, but I have a Git repository. Instead of storing the Jupyter notebook, it stores a link to your Git repository. From the system perspective, it's just a string to where we can find the Git repository. And it will also store the uncommitted changes, because we learned the hard way that if you want to reproduce something, you have to store them, because we're all messy and we forget to commit them, and they contain some very important parts of our code. So we store that alongside the link to the actual commit that you had locally. And then on the remote machine, on the AWS instance that we spent before, alongside the AWS credentials, you have to provide your Git credentials so we can actually pull your code into that machine. Then we apply the uncommitted changes, basically replicating the same repository as you had on your machine. And again, installing all the different packages and running your code. Now, when you think about Git repository, usually you have argparser or Hydra or Python Fire. That's part of the AutoMagic. We hook into those and we make sure that every configuration that you see in the user interface is being passed automatically to those objects in real time on the remote machine, which means that now you can add it your Hydra configurations and your arguments and everything from the UI itself without actually working hard on exporting them, just by using the right packages.
And at the end of all this, I should hopefully have developed some model. Can you talk about that path, which I've seen so many homegrown solutions to go from there to production?
Oh, okay. I had this conversation with a friend. I think it was a week ago, and I think that we got to the conclusion that most people still do homegrown. I think I am not actually sure why. Maybe because it's easier, and our suspicion is because the people in charge, and this is hypothesis. We don't actually have a lot of data, only anecdotal, to support it, but that's the theory, is the people that are in charge of deploying it are software engineers. And the easiest way to go about it is containerize every model in a single container. And then from that point onwards, it's solved, because we know how to deploy containers to the cloud. And this is how people approach it, which is not very efficient and very hard to scale. But that, I think that that's kind of the intuitive approach to, okay, we have something to deploy, that's what we do. Do you agree to that, or is it just us thinking this way?
No, that lines up very much with my experience. So we have at least two anecdotes in the room. Yeah.
I think it's just different people, and that's kind of how easy it is for them to. At the end, we're machines. We like patterns. We find a pattern that we like. We basically match everything to that pattern. That's how we work as people, and I think that's a pattern that is currently available for a lot of people, and that's what they use in order to solve this problem. But actually, it's not very efficient. So first, unless your model is very highly used, then it's actually more efficient to deploy multiple models to the same container, because resource wise, it might be standing idle. This is a service. You cannot take it down. So you want that resource to probably provide a solution for multiple models. That depends on the load of the system. But in a lot of cases, think canary deployment or A/B testing, or maybe something that is not very often used, then you want to actually optimize your resources. Otherwise, every model will get its own container. Every container will end up with, you have a limit per node. You end up with just spending a lot of money on CPUs or GPUs doing very little. So that's the first aspect. And then the second one is you should probably add some telemetry on top. First, just generic one, like how many times people actually call that endpoint or the request or the model, however you expose it. And then hopefully later on the performance of that specific model. What exactly is it getting and outputting? So you have some visibility, and then with that visibility, you can actually build like drift detection and some automation on top, etc. But I think adding those as just someone else's problem. You know what I mean? Like it's not a software engineering's problem. So usually people just say, "Oh, we just deploy it." And this is kind of the initial missing part for them, but it's actually the missing part as infrastructure to use. Does that make sense to you or
Yeah,
resonates
yeah.
with your experience?
Yeah, that makes sense to me. I think I probably understand the anticipated production load a little bit better than some random DevOps person will. And I want to collaborate with them, but I definitely want to play some role in making sure everything's set up well. And if there was some tool that I knew just magically worked, I could throw it over the fence, maybe I'd use that. But I don't know if I think that's state of the art. I think everything right now is going to need my involvement, and maybe it's going to stay that way. But it does seem like more and more parts of the process are certainly going to become automated or easier in lots of automated ways. I think both the best practices and philosophy around the ways of doing these things are maturing, and so are the products that help us do that. And with that in mind, that it's I guess an evolving field. Can you share a few thoughts on how you decide the direction ClearML goes in? How do you prioritize what comes next?
So the way that we developed ClearML, so I can't remember if I mentioned. So ClearML is open source. The way that we actually develop features is basically community feedback. So if people ask enough times on something or a topic, we just open it up and create a discussion and actually ask people what they do and what they want. And this is what we did with the serving, which is relatively new in the ClearML universe. When we approached users, when they ask, okay, guys, do you have something for that? What do you think about serving? I think that the first thing that users wanted was the ability to very quickly update models. The second one was the understanding that models need to have some pre-processing before or after, and the model itself is something that is changing, but also the pre-processing sometimes together, sometimes not. The third one was a view into what's going on with the model itself. We developed a way to actually introduce a solution that actually scales, that supports different types of models with different types of pre-processing before and after, that you can upgrade from a command line interface without, or programmatically, without changing your infrastructure. And the reason was the people that we talked with were not the DevOps spinning the clusters or the containers. So they wanted the DevOps teams to just spin a cluster for them or containers or however they wanted it to work. And they, meaning the machine learning practitioners, wanted a way to send new models, get visibility into the models that are being used, and have the ability to actually write code for the models without changing anything in the infrastructure. And that was key for them because if we move it or shift it to the production side, we'll end up with the same solution as we had before. Guys, just dump it into a container and spin it. And that was not a very good one.
And I'm curious if you've seen any patterns in maybe the type of company or the industry who's really on the cutting edge of adoption, making the most out of these tools.
I don't think it's limited to the specific vertical. I think it's limited to the type of application that is being built. We've seen a lot of companies in fintech and insurance deploying models, companies doing a lot of things with computer vision, medical, but it's all over. We are quite agnostic to a specific vertical. So if these are new applications, then machine learning is built into the design of the application, like the product, I mean. But sometimes it's kind of added as an afterthought. In most cases, like in most products, you see it as an afterthought. And then since it is an afterthought, it's a lower priority. It was never part of the product. So you see a lot of things just they get delayed, even though that afterthought could make a lot of money or save money or do whatever good for the
Yeah.
product. It's an afterthought. So, it's not perfect. Like, it's not 99% accurate. So, we cannot deploy it, even though that depends on the use case, right?
Yeah. Well, as we record here at the, I guess, beginning of fall 2022, I mean, deep learning's been making headlines for years, but it's computer vision that's been making all the recent headlines. When you think about computer vision as, I don't know, one subcategory of ML, does it need special tooling or anything to help those specific types of projects?
So, I think that these days we hear about computer vision and NLP. I think that's kind of a more sexier parts of machine learning
Yeah.
because they sound so sci-fi, and they are, and you
Yes.
see it and you think to yourself, oh, this is amazing, it's unbelievable that it actually works. What we tend to forget is in order to get those models to work, the amount of infrastructure that you have to have is enormous. Actually, most of the time you invest in infrastructure. If it's computer vision, you have unstructured data, so images and videos and whatnot, but it's the annotation that is very hard to first get and then manage. For example, just the fact that you need to oversample data and augment the data because you never have enough samples, because those models need a lot of them in order to converge or at least start with a very good model. And the fact that things change and the fact that you have a lot of knobs to turn in order to create the final effect on your model means that you really have to have a very good infrastructure so you actually expose just the knobs. Otherwise, it's manual and you will never get to a model that is stable enough. And the second challenge is getting to a model that is stable enough. Even if you were able to produce one model that works, making sure that you can reproduce it on new data, on changes in the code base and changes in the annotations or the data sets is key to actually being able to use it. Otherwise, it'll be a great demo, but it will never be incorporated into the product itself. I think that the same goes for NLP. Same type of problem, just visually it looks different, but from an implementation perspective, it's essentially the same.
Well, as a hands-on practitioner, I see a lot of reasons why I would want good tools like the ones we've been describing. They'd help my project move faster, give transparency, all the typical reasons. Are there any other personas you think about? Is there like an engineering manager or a CFO or someone like that who gains benefit from the platform as well?
One of the missing stakeholders from a lot of the discussions are the business units. Just because these are, at the end of the day, our developer tools, and we think about ourselves as the customers, we're not the only customers. And the driver of machine learning and deep learning is always the business unit. It has to connect to the product itself and it has to create value for the product. And I think the missing part is actually embracing the business unit as part of the development. If we expose the data and the process to them, they can say, you know what, 90% is fine. We can work with that. Or we can use it in a very specific scenario, and that's still fine. Don't worry about the other 90% of the scenarios. The fact that you can solve 10% of the scenarios with very high accuracy, that's good enough. That's an improvement. And I think that those discussions are missing. I think that it hurts machine learning adoption because at the end, we cannot have everything working perfectly. And in order to make those compromises, we have to create the visibility and the communication. And I think that's a huge part that is missing.
I would guess that a lot of your signups and interest come from people like myself, ML practitioners who have been waiting for a tool like this. Are you seeing any other inroads? Are there business units that are discovering you first?
Not yet, to be honest. I would have loved that to be the case, but I think that for a lot of business units, this is still kind of magic. Right now, they're still in the position where they're waiting for it to happen for them internally, but I think it'll grow. And I think that we need to better educate business units on what's realistic to expect and how to create the discussion on machine learning and the performance of a machine learning model and how to develop one together with them, as opposed to, hey, I just want something to do some magic for me, which is usually the case these days.
So the tools I've used have evolved over the last 10 or 20 years, but not so much the methods or the techniques. I'm still doing a lot of the same underlying ideas, get my data, do feature engineering, train, test, this kind of stuff. Do you think that will be universal, or will the tooling evolve to the point where in 5 years, the manner in which I do my job will be radically different?
I think that in computer vision and NLP, it drastically changed. If 15 years ago you actually had to manually come up with visual features or linguistic features, these days you don't have to. Like, that's built into the training, finding those features. What you're doing is something else. I'm not saying that finding the right combination of different labels or classes isn't important. I'm just saying it's not feature engineering. Hopefully that can be automated as well. And I think that in tabular data, we'll be seeing the same type of progress where instead of just finding more manual feature engineering, just it will be just, hey, just feeding all the data and get a bigger model to learn from the raw data instead of someone actually building the new features.
Well, as systems grow and as we take on more of those automated feature engineering options, it separates me a little bit from what's actually going on, leaving, questions for model interpretability and AI explainability. How do these themes fit in with your platform?
So this is only in the making, basically analyzing or forensics of models, trying to explain how the models work. I think that generally speaking, it makes a lot of sense in very specific fields where you need to provide a specific level of provenance over the model itself. In some of them, the fact that it's magic and it is unexplainable, I am not sure that's very important to the performance of the model or the development of a new version. What do you think?
It's tough to say. I think it's an evolving area, and my opinion keeps swaying one way or the other. Time will tell, I guess.
I'm with you. Time will tell. I mean, now that at least we have some tools to explore those very large black boxes, which is better than what we used to have.
Yeah.
So,
Yeah. And what about the business? As the tooling around ML becomes better, maybe companies can start to have higher expectations. Do you see an acceleration in the go to market of ML solutions?
yes, I think that the market itself really matured in the last couple of years. I think that maybe 2 3 years ago, people did not actually understand that they need to have any infrastructure, and I think that today machine learning practitioners are actually actively looking for a solution. I think that in terms of market education, we actually evolved quite a lot, and I think that we'll still see that progress towards how to actually shift towards CI, more of a CI/CD process, and actually automating this entire end-to-end line.
So CI/CD sounds great when it comes to software. If, an engineer says I've got a new feature and we can have it released this afternoon after QA approves, that's great. I'm not sure if I want perfectly, fully, as fast as possible ML releases. Maybe we need to do some analysis on these before we push things out so quickly. Do you have any thoughts on the matter, or are you seeing any best practices emerging?
Right. I think that we imagine CI/CD as a red green screen, basically. Like your CI passed and then you go into deployment, right? That's how we
Yeah.
imagine it because that's what we have now. But when we think about CI/CD of models, and as you mentioned, like there is no green, I want to see the graph, and then I want to decide if that graph is better than the previous one, because the fact that my F1 score is better does not mean that I want to deploy it. There is coverage, so I want to actually see it. So my point is, we should shift from kind of a binary CI/CD process where we kind of imagine, okay, pass, fail, into I want to see some graphs before I decide pass, fail, and then maybe I do that manually, but it's still a click of a button and then I deploy it. And I still want to see the graphs once I commit a new version of my code, or someone else commits a new version of the data or a reference to the data, because that kind of makes sense to have as part of the process. I'm with you that it's not a fail pass anymore.
I know we've only covered some of the features and options ClearML has to offer. Can you recommend some good resources for listeners to go and learn more?
So our YouTube channel is actually quite nice. So you go check out the YouTube channel, subscribe so you can get notifications on new videos. We actually upload them once every week or so. So new content with basically exposing different features, best practices. It's actually worth it. Log into our Slack channel. It is very, very active. We actually help people build some crazy things. The community is quite large, and you can ask very technical questions on MLOps and on training, on scaling things. I'm sure that you'll find your answers there. Also on our GitHub pages. So you can go to the GitHub and ask questions, issues, stars, of course. And you obviously can check the open source and the fully free version that you can find fully hosted on our website.
Excellent. We'll have links to all the above in the show notes for people to check out. And Moses, is there anywhere someone can follow you online?
Find me on LinkedIn. I think that's the easiest these days.
Sounds good. Well, thank you so much for taking the time to come on and share your project.
A pleasure. It was really awesome.